Okay, so now we're going to look at chapter 22, which talks about managing our waste. We've talked about some toxicology. We've talked about um, the size of the human population. So now we're going to talk about where all the waste goes that our large human population produces. Oops. So this is what we're going to talk about. These are our objectives for today. You've had one piece of legislation, that's the Endangered Species Act. You're going to get two more in this lecture, so I'll point those out to you. So waste, by definition, is any unwanted material or substance that results from a human activity or process. There's the Captain Obvious statement for our lecture today. And there are a few categories. So there's municipal solid waste. They abbreviate that MSW. It's non-liquid waste that comes from homes, institutions, and small businesses. It's what you put out on the curb at the end of your driveway that the trash truck comes and picks up. Okay. Industrial solid waste comes from industry. It can be more extensive and more difficult to deal with than municipal solid waste because of the stuff that's in it. Hazardous waste is any solid or liquid waste that is one of those four things: toxic, chemically reactive, flammable, or corrosive. And we're going to talk about those different categories a little bit later. And wastewater is water that we drain or flush. So when you flush the toilet, when your dishwasher drains, whatever goes out of your sink or a toilet or anywhere where water runs in your house, what leaves your house is wastewater. We need to manage waste, and that is part of the challenge with 7 billion people on the earth. Waste is almost inevitable, but there are ways that we can manage that waste. So the first way is to minimize the amount of waste we generate, essentially produce less waste. And there are ways that we can do that. We can recover things that we've thrown away and find ways to recycle them. Or if you can't, if it's waste that you need to generate, how do you dispose of it in a way that's safe and effective? So the waste stream, and they talk about this a lot throughout the course of this lecture, is the flow of waste from where it becomes waste when it gets discarded to where it eventually winds up for the long term. So the first thing that they talked about is minimizing waste, okay? And the way that they do that is called source reduction. And it's really the easiest way of dealing with the waste stream. So instead of sending all of this stuff to disposal, the landfill or an incinerator, we're going to talk about both of those, what can you do to minimize the waste in the stream? Well, you can reuse items, you can recycle items, you can compost things. This is big. This is so huge. Minimizing packaging for products, all right? Instead of getting a plastic bag for your vegetables at the grocery store, just put them in your cart, okay? Or bringing your own bags to the grocery store, all right? Or purchasing products that are green, that are made of recycled materials or anything like that. But minimizing waste, to start with, reducing the amount of waste in the waste stream is the easiest thing that we can do. So when you look at products from where they are manufactured through their whole life cycle to where they wind up, they call that cradle to grave, all right? And we're going to hear that term cradle to grave a little bit further down the line. There's an idea, it's called cradle to cradle, that says that materials from products are recovered and reused to create new products. So I heard something, I think it was on my Fact of the Day calendar, that Kit Kats, the candy Kit Kats, they're never wasted, right? So if there are any Kit Kats that don't meet the quality standards, they get recycled, put back into the system, and the filling inside the Kit Kat is actually made of Kit Kat. So that's a delicious cradle to cradle approach that I can totally get behind. Another couple of ways that we can handle the waste stream is to recycle or compost. We're going to talk about compost when we get down the line into our agriculture unit. So you take organic waste and you turn it into mulch or humus, not hummus, not the chickpea paste. It's humus through decomposition. And they are both similar to those natural cycles that take place in ecosystems. What we try to do in as many human processes as we can is to turn our cycles and our systems into to help them mimic natural systems, because natural systems work. Recycling and composting are recovery because they pull waste out of the stream. So if you have a composting bin at home, if you recycle at home, you're recovering that material so it doesn't wind up in the waste stream. What goes out to your curb or the side of the road into your driveway is municipal solid waste. It's trash, it's garbage. So if you look at the left graph before recycling and composting, more than a quarter of what goes out to the curb is paper. All right, food scraps and yard trimmings and plastic make up the next bigger portions. After you recycle and you compost, even still, food scraps, because you can't compost everything. Food scraps are the biggest part, followed by plastics and paper. All right. So recycling does reduce waste in the waste stream. Compost does also. This kind of makes sense. This is another Captain Obvious statement. Consumption leads to waste. All right. So waste generation has gone up significantly since 1960, when affluence went up, and the things that you buy aren't as high quality anymore. So we kind of have a disposable society. Belts and clothes and stuff were maybe more expensive back before 1960, but they lasted you for a really long time. So you actually wound up outgrowing them before they broke down. All right. So we're packaging things in more packaging than what we have in the past, and the goods just aren't lasting as long. They're not as high quality as they used to be. In a developing nation, you see a similar trend that waste production and consumption go up as developing nations move across that demographic transition. So those who are not increasing their affluence, like you see in this picture that really makes me sad, they scavenge dumps like this, huge groups of people, and they sell stuff that's been scavenged from the dumps in a way to make money. In developed countries, waste collection and disposal has gotten better, and recycling has gone up, combustion has gone up. So there's less trash going into the landfill per year. So you can see this brown line. It started up, and if you had projected it out from like 1985, assuming the same slope, there'd be 200 million tons of waste in the landfill a year. But it's kind of leveled off, right? Recycling really started to become a thing right around the time I was a sophomore in high school. So that was 1990. So you can see the jump up in the late 80s and early 90s when it comes to recycling. And composting, in the mid to late 80s started to be a thing too. Whoops. And we kind of talked about this. It's really easy the easiest thing to do is to just reduce the packaging. You can take your own plastic bags to the grocery store, and you can buy food in bulk, all right, instead of in little tiny packages. And there are governments where they're taxing and restricting plastic shopping bags. I believe Governor Murphy signed a ban on plastic bags in New Jersey recently. I don't know when that starts, but it kind of makes sense. I know I had a girl in class that graduated in 2015. I had her as a sophomore, right after I had Erin. And she was leaving New Jersey to go out to California to study. And, she told me, Mrs. Grady, you can't use plastic trash bags out there. And I went, oh, okay. So she goes, I don't know what I'm going to do. So her graduation present, I went on Amazon and I bought her 10 reusable shopping bags. And that was, my gift to her. And she laughed at it, but I actually spoke to her, I'd say at the beginning of the school year. She said, I still use them. And I said, oh, fantastic. So it actually happens. California is a little progressive when it comes to stuff like that. But it's moving its way this way too. These are just some things that you can do to reduce waste, okay, or to reuse items. So reusable cloth shopping bags. When I was making photocopies, I was making them double-sided as much as possible. One thing about a pandemic is that, I'm not printing things as much as I used to. So you guys are not getting anywhere near the amount of paper that I would have given in a non-pandemic year. I bring my own coffee cup to a coffee shop. I don't use plastic silverware. I bring my lunch to school every day. Sometimes it's soup, sometimes it's salad. And I 2 or 3 years ago, actually bought a spoon, a knife, and a fork, and I keep it in my desk drawer so that way I don't have to keep wasting them. I'm guilty of some things. Paper towels and paper napkins are always a thing in my house. I'm trying to get away from plastic wrap, so I use reusable plastic containers. But it's hard. Some of these things are more difficult than others. So compost is something that you can do to recover organic waste and turn it into mulch or humus through decomposition. You put bacteria and worms in there, and you can cycle matter through decomposition rather than it heading into a landfill or an incinerator. And in most years, kids have told me there are at least 2 or 3 kids in a class that have a compost bin or something like that. Even last year in my class of 4, I had a student with a compost bin or a compost pile. Edmonton in Alberta in Canada composts about half of its waste stream. All right. So that's the compost factory. It not only has about half of its waste stream, but there's dried sewage sludge in that gigantic aeration building. I'm really kind of surprised that the lady that you see right there is not wearing a mask, because I can't imagine it smells very good. In a lot of cases, you can't, in New Jersey, I know that for a fact, you can't do anything with sewage sludge. In Pennsylvania, you can get it down to a certain content of ammonia and sell it as fertilizer, moisture content and ammonia content. But you can't do that in New Jersey. Apparently you can do that in Canada, because this is going to wind up being a fertilizer type material for I don't know what kind of plants, but that's that. So if you're going to recycle, you have to collect the stuff. And then from your house, it goes to a materials recovery facility. They separate the recycled items by weight using magnetic pulleys, optical sensors, and all of these really high-tech things. Back in my day, when recycling first started to be a thing in the late 80s, we went to a recycling plant, and a lot of, as a school trip, and a lot of the recycling was done by hand. Things weren't labeled very well, with the recyclable plastic label. Things have gotten a lot better since then. And once everything is sorted, the stuff can be used to manufacture new goods. So it's gone up quite a bit since the late 80s. As much of a a little bit over 6% of the waste stream was recycled in 1960. And as of 2013, it's a little bit more than 25%. It's getting better, but there's still a ways to go. And we're going to talk about why it's not quite as prevalent as it should be. You guys are going to do this. You're going to do a trash audit. It's going to be a Flipgrid assignment. You're going to kind of like look at the trash you produce for a week, and then you're going to answer a couple questions about it. Recycling varies quite a bit from one state to the next. So your dark green are the higher recycling rates. Yay, New Jersey. New England, some random states in the Midwest, and California are all pretty good at recycling. But there are a lot of states that don't recycle. And it makes me sad, because it's not that difficult. Some of the things that we do recycle quite a bit, the good thing is that batteries frequently get recycled, which is really good. Because those are no good to have in landfills. Plastic isn't recycled anywhere near as much as it should be. All right. So why isn't recycling so much of a thing? And this is the reason. World oil prices right now are really low, lower than they've been in a long time. So when world oil prices are low, it's cheaper in many cases to buy new plastic or to make new plastic as compared to the cost of recycling plastic. All right. So there's got to be some incentive if we want recycling to continue. There's got to be some incentive for, making products out of recycled plastic rather than new plastic. I don't know what that would be, but if we want to encourage recycling, then there's got to be some benefit to it other than financial or more than financial, although I don't know what that might be. And the same thing when, metals are low, when the prices of metals are low, it's going to be cheaper to mine new metal than it is to recycle, right? So the scrapping industry, if you guys know anybody who collects scrap metal and then turns it into recycling, their profits have gone down quite a bit. So when we look at this cost benefit analysis, we're only looking at the financial side, okay? We're not taking into account these external costs of not recycling, like the greenhouse gas emissions, like when we're talking about mining metals, the impacts that has on the ecosystems and the land itself. And we'll talk about that when we get to the mining chapter. So this is just looking at the financial costs and benefits, not those external costs. So one way that you can help reduce waste is to give some financial incentive because, money is a great motivator. And there used to be things called bottle bills. I don't know if you guys have seen it. It's a law that has consumers pay 5 to 10 cents for a deposit for a recyclable container that's refunded when they return that to the store. New Jersey used to have one. I remember when New Jersey had one. But Michigan's is 10 cents per can or bottle. So you pay 10 cents extra per can or bottle, and then you collect all of them and you take them to a store, and then they give you that in Michigan, that 10 cents a bottle or can back. So it's a way of recycling. And statistically, states with these bottle bills have 3.5 times more recycling than those that don't. So, and you can see that, all of these states without the bottle bill have next to nothing. And then all these states with it have a much higher rate of recycling. So it works. Where does most of our trash go? If we don't recycle it, if we don't compost it, it goes into a sanitary landfill. All right. If you drive on Route 78 from New Jersey through Easton, heading towards Allentown and Bethlehem, heading west, you pass this giant hill on the left-hand side as you're headed west. And that's the Schrin landfill. That's where our trash goes. So all the trash from this area eventually makes its way to the Schrin landfill. All right. The landfills have to adhere to standards set by the EPA under the Resource Conservation and Recovery Act, otherwise known as RCRA. This is a piece of legislation that you need to know. Municipal landfills have to follow RCRA. All right, so make sure you know that one. So how is it built? All right, so this picture is on the next 2 slides. So I'll kind of talk about it now. So at the bottom of the landfill, right, this green layer, all right, underneath that, sorry, this yellowy layer is compacted impermeable clay. So it's like the clay that you use in art class. It's real similar, only it's compacted. They smush it and smush it and smush it and smush it to make an impervious layer, to not allow any stuff that's in the landfill to get out, to leak, and get into the soil and the water around it. All right. Above that is a plastic liner. It's a big trash bag, giant, thick trash bag that they put in over top of the clay layer, again, to prevent leaking. All right. Above that is a gravel layer, kind of like a driveway. And within that gravel layer are pipes that collect a liquid that comes from the landfill as the trash starts to decompose, called leachate. It is one of the grossest words in environmental science. Ugh. Leachate. Okay. Above the gravel leachate layer is a granular drainage layer. So this is usually sand or something along those lines. And sand and gravel allow liquids, this leachate, to percolate through, to get from wherever it's generated in the layers above down to the leachate collection pipes, so that leachate can leave, as you see on the right-hand side here, and get treated. Okay, so if you look at where they put the trash all together, all right, they layer the trash. The darker brown is the solid waste. They alternate the layers of trash with soil. Okay, so it's kind of like, it looks like bricks to me. So they're building the landfill out of bricks. Putting soil between the bricks of solid waste reduces smell, it reduces pests, and it kind of gives bacteria their own spot to do their work. All right, to do their decomposition. Landfills in general, as a part of RCA, have to be located away from wetlands. All right, because that wetland soil is soggy and will soak up whatever's there. Any earthquake-prone faults. So if it's an earthquake zone, it's got to be far enough away from the fault, and at least 6 meters above the water table. So the distance between the bottom of this clay layer and the top of the water table or the aquifer has got to be at least 6 meters. Okay. All right. So they can do a few things with this landfill. So they treat the leachate that comes out. Most of the time that's considered hazardous waste, so they have to deal with it separately. They're constantly monitoring the groundwater, all right, so the water underneath the landfill, to make sure that there's no contamination. And something else that they can do, and we'll talk about this in a second, they can, as decomposition takes place, methane is one of the gases that's produced other than carbon dioxide. So they can turn that, they can concentrate that and use that to generate electricity. And I'll tell you a story about the Schrin landfill in a couple minutes. So when landfills get used, on the left, Fresh Kills landfill is Staten Island, I believe. Yes, it is Staten Island. That's what it looked like. And then they capped it and, built grass on top of it and let it kind of go back to nature. So it becomes a park. Somebody told me last year that he played baseball in an old landfill up in northern New Jersey. Okay, so let me go back to this methane gas recovery well. So the Schrin land, I had to write a paper when I was in grad school on where our trash went. And I figured out it was the Schrin landfill. And they were very hesitant to talk to me. They didn't want to, didn't know who I was, even though I left them voicemail after voicemail after voicemail. They refused to talk to me because they just didn't want to say anything, which was very frustrating because I'm trying to write this paper. Turns out they had recently been hit with a lawsuit regarding some leakage of leachate. And they were also, once I finally got a hold of somebody and convinced her that I wasn't out to, write this slanderous essay, I just had questions I needed to answer for my paper. I was frustrated. It probably took me half the semester. I started the class in January and I probably didn't get through to them until mid-March, something like that. So I kept emailing my professor saying, look, I'm trying. I called them every day this week and they haven't gotten back to me. Their home offices were about 3 miles away from the landfill itself. So they were in the process of building their office building to use this methane gas to generate electricity. So the main reason why they were having issues is because there was a lot of public opposition to them, running the natural gas lines from the landfill itself to that 3 mile distance to their offices. So they were really hesitant to answer questions, but I convinced them. Okay, so one thing that we can do to reduce the pressure on a landfill or landfills in general is to incinerate or burn trash. It's burned at a really high temperature, and the big perk of incineration is that the weight of waste goes down, about 85%, and its volume goes down about 95%. So there's much less material going to the landfill, so landfills will wind up lasting longer. So this is what happens. All right. So you take the waste and they dump it into a pit, and the crane puts it into the boiler, into the furnace, right? And it burns. And one of the boilers has an enclosed water system where the heat from the burning trash heats the water, which turns a turbine, which generates electricity. So that's, one benefit of incineration. The stuff that's left behind is called ash. All right. So the ash will make its way for treatment and then disposal, or just straight disposal in a landfill. To follow the Clean Air Act and other legislation we'll talk about in upcoming chapters, that gas that comes out of incineration has to be scrubbed. It has to be cleaned. All right. It's got to be neutralized and then gets filtered through this thing called a bag house before it's released to the air. All right. So it physically filters the air from the ash. A lot of, and this is kind of what we just talked about. A lot of incinerators are now waste to energy. So they can use that heat to do something other than just produce heat, to generate steam, to turn a turbine, to create electricity. All right. And then the landfill gas is the other thing I talked about, where you can use that to generate some kind of electricity. You can burn that methane gas or landfill gas, to generate electricity. You could dig into landfills to salvage some materials that are recyclable. You could also mine organic waste out of a landfill. But again, the cost has to be beneficial. The benefit has to outweigh the cost. All right. So now we can talk about industrial solid waste. It's anything that comes from factories, mining, etc. To get rid of it, it's similar to municipal waste. So there are regulations in place and for industrial waste. So if you look at who regulates what, the federal government regulates municipal solid waste, the RCRA, all right? State and local governments regulate industrial solid waste. So there are generally fewer restrictions on industrial solid waste than there is on municipal solid waste. So that can be good, but that can be not so good either. And typically, industry bases most of its practices on economic efficiency instead of physical efficiency. So they're going to do what's cheap rather than what is less waste generating. So their cost benefit analysis isn't necessarily geared to thinking about what's environmentally best. They're concerned with what's economically best. We can throw ecology into anything. So industrial ecology is a way to model industrial processes to work like ecological systems. So that way you're maximizing the cycling and producing less waste. But that involves not only making changes to industrial processes, but a major shift in thinking about products that you create. It's a nice idea. I just don't know how practical it is. And they do that through life cycle analysis. All right. So they look at a product and look at all of the different parts and processes that went into making that product and looking at ways to make it more efficient. All right. And there's some examples. Hazardous waste. There are 4 different, in order to be classified as a hazardous waste, it has to be one of these 4 things: ignitable, corrosive, reactive, or toxic. Okay. It can be any combination of those, but it's got to be at least one of those things. Most of the hazardous wastes are industrial, but there are a lot of household hazardous wastes in your house right now. I cleaned my shower with bleach yesterday, and that is a hazardous waste. Oils, batteries, paints, etc. Pesticides. If you guys have Roundup in your garage or in your shed, that's a hazardous waste. Some of the organic compounds that we talked about in chapter 14, mutagens, carcinogens, teratogens, endocrine disruptors, are really, really nasty. Okay. A lot of the man-made synthetic organic compounds are toxic because they get through your skin really quickly and they're persistent, right? They don't break down easily, so they tend to bioaccumulate. Metals like lead and mercury are fat soluble and they break down really slowly. So when I was pregnant with Aaron, they give you a whole list of things not to eat. Deli sliced meats because there's a risk of listeria. And of course, all I wanted was salami and cheese. They tell you not to eat raw fish and soft cheese. Okay, no problem. But they also told me not to eat more than 4 ounces of tuna every 2 days because of mercury. And I couldn't eat the albacore tuna. They said I could only eat the chunk light tuna because of the amount of mercury in it. And of course, like every other day, I wanted a whole can of tuna. I saved it for my Friday. That was my Friday treat. Because mercury is gonna, mercury bioaccumulates in the fish's body and lead too. So I didn't want to expose myself and therefore Aaron to any of that. So they do cause hazards on a lot of levels. Electronic waste is another big thing. Your cell phone, MP3 players, anything that you have that you've gotten rid of has flammable chemicals and precious metals in it. And when that winds up in a landfill or an incinerator, you're putting those materials, those wastes, those toxic wastes into your soil, into the air, or into the water supply. In a lot of cases, e-waste is considered a hazardous waste. Couple things that are kind of reducing the impact of e-waste. The devices that we have are smaller than they were, and that we're having e-waste recycling drives. So you're getting rid of the e-waste properly rather than just throwing it in the landfill. I have an iPhone 11. Before that, I had an iPhone 6. Before that, I had an iPhone 5C. And before that, I had this really cool LG phone that like opened up like a book, and you could like text. There was a keyboard and a screen on the inside. I still have all of those phones because I haven't found a place that I, just want to get rid of them. Aaron thinks it's cool. It's like a walk through history. I was like, okay, sure. And you can sell that material, those rare metals. And the 2010 Winter Olympics in Vancouver, they produced some of their metals from partially recycled e-waste. And I think that's kind of been a thing since the 2010 Olympics, that they're doing that more and more, which is good because it shows like a commitment to the environment from the IOC. Things have to happen before hazardous waste is disposed of. You guys, I think you guys agreed to the case study on the Love Canal disaster. If not, then we can talk about it when we talk about this in class. So before the 1970s, before the Love Canal disaster, hazardous waste was just put wherever. It was buried in the ground. You can do whatever you want with it. Doesn't matter. Nobody tracks it. RCRA this is another thing you need to know about RCRA. RCRA set standards by which hazardous waste has to be managed, okay? Hazardous waste has to be tracked cradle to grave, like we talked about before. So from where it's generated to where it ends up, to where it's finally disposed of. And you can't just put hazardous waste anywhere. There are certain spots for it, and they track it, and they have records of it. It's a big deal now after what happened at Love Canal. So the EPA needs to know everything. They need to know what's generated, how much is generated, where it is now, where it started, where it's going, and how it's handled, okay? That means that it's expensive because you have to have it tracked every step from beginning to end. And that's an expense depending on, the finances of your company that you might not want to incur. So what happens in a lot of cases, sadly, is that waste gets dumped illegally, or they export it to developing countries. So they have to deal with it. And you know what? It's worth, to some of these companies, it's worth the whatever cost it is to not have to have that hassle. I don't personally agree with that, but different people, different things, as is the saying in my house. 3 different ways that we can get rid of hazardous waste. So the first is a surface impoundment. And if you ever drove or remember driving between Frenchtown and Milford along the river, the Regal paper mill was there. I forget what else it was. It's gone. But that's a super fun site, and a lot of you guys took pictures in front of it. So there were little ponds. I say little, they were probably 200 feet across, maybe 100 feet across, that had plastic in them, and they had this green liquid in it, okay? That's the liquid hazardous waste. So that was a surface impoundment. That water evaporated, the solid residue was taken out, and then it was put elsewhere to some hazardous waste dump. Another method is a deep well injection, where they drill way deep down below the water table into porous rock that has space in it, and waste gets injected that way. But that's risky because that waste can leak into soil or into aquifers. And when you do that, you also open up the pores in rocks and the faults in rocks, and you can cause earthquakes, which could then cause more issues. Radioactive waste is really dangerous, and we're going to talk about that when we get to Unit 6. It's even after radioactive material is no longer useful in generating energy at a power plant, the material is still radioactive and can still hurt humans. So it's got to be dealt with. Currently, we don't have a site for it. There's no one place for everything to go. They have tried to put it in this mountain in Nevada. It's called Yucca Mountain. They've been talking about putting nuclear waste in Yucca Mountain for my entire teaching career. But it has since recently been removed from consideration, so they don't put it there. There are a bunch of nuclear power plants that hold nuclear waste across the country. But the problem with that is, if terrorists figure out where it is, they can steal it from a bunch of different places. Any military nuclear waste is stored in New Mexico in a salt formation that is, they believe it's geologically stable, or is at least geologically stable for now. So radioactive waste is a big thing that we need to deal with. And we'll talk more about that when we get to Chapter 20 in Unit 6. So before, Love Canal and all that stuff, when waste was just kind of thrown places and not, disposed of haphazardly, there's lots of places around the country that we're discovering, there are issues related to waste disposal. So in 1980, Congress passed something called the Comprehensive Environmental Response, Compensation, and Liability Act. It's called CERCLA. All right. So CERCLA created something called the Superfund program. So the paper mill in Milford is a Superfund site. All right. There's hazardous waste there, like those ponds. And CERCLA allows for it to be cleaned up through the Superfund program. Later laws also charge the EPA with cleaning up some things called brownfields, of which the property that used to be the Milford paper mill was full of. So it contained hazardous materials, whether that's surface impoundments, whether it's barrels buried under the ground, anything like that. So brownfields and the Superfund site are all part of CERCLA. And so this talks a little bit about Love Canal. Toxic chemicals were buried by a company in Love Canal, New York. It's not far from Niagara Falls. And those materials rose to the surface, basically creating toxic chemical puddles, which contaminated homes and an elementary school. The land was sold to a developer, and then a community was built on top of it. So there's some evidence that links those materials to birth defects, miscarriages, cancer, cells, cancer clusters, and a number of things. So when a Superfund site's identified, scientists prioritize the site based on something called the National Priorities List, looking at the extent of damage that could come from that waste getting out. Okay, how confined it is or how likely it is to spread, and what it could do if it were to spread. 2016, 1,328 Superfund sites were on the National Priorities List, and only 391 had been cleaned up or deleted. As of most recently, the Milford paper mill, the Milford paper mill has been removed from the list, and that's something we can look at when we get together to talk about this in class. So that covers waste management. I hope you guys got something out of it. Thanks for watching.